Hey guys, this is Chris Forbes, Mr. Forbes, whatever you want to call me. Coming to you with our first video in a series of videos on Math 1, teaching Math 1. Now, as I said, we are going to be using the standard course of study. We're going to be using the CCS lessons and pacing guide as we go through all of these videos. My goal with you, as I've said in a previous video, my goal is to um, just be an extra resource. Help as much as I can with teachers, with students, wherever I can. Hopefully, somebody's able to get something out of these, whether it's an explanation, whether it's how to teach it, whether it's how to learn it. I don't know, but my goal is to go through each of these and how I process it. So I am by no means an expert teacher. I don't claim to be, but I just wanted to again provide an extra resource, right? So, starting with lesson one, this is unit one. It's on equations and inequalities. That's where we're going to start in Math 1. And we're going to kind of do a little intro here. And again, I'm just going to explain my reasoning as I go and a few things to keep in mind. As I always say, um, this is live, so I don't even know how to edit a video yet. So, what you see is what you get. I make mistakes. That's human. You're going to hear some noises in the background because I have a very loud baby and a very loud dog, so that's okay. But it's going to be good. We're going to learn as we go. All right. So jumping right into it. Every time we have a lesson, I'm going to do the same thing. I want to state what our objective is. I want to state so you know, the kids know, everybody knows what to expect in this lesson. All right. So it's right here at the top. It's squared off for you. Today, students will be able to and I'm not good at writing yet, so bear with me. Aha! Determine which values in a situation can vary. Mm-hmm, mm-hmm. Yep, that's awful. And which cannot, in order to understand what a constraint means on quantities and expression. Like I said, we're learning about what equations are. We're learning about what they mean. We're learning about what expressions and quantities are. And in those, we have certain values that can vary. We have certain values that are constraints that restrict what we say in our equations. So today's lesson is all about understanding how to read expressions, how to understand what they're saying based off of what can vary, what can change, and what our constraints are, what limits us. Okay. So we're gonna think about planning a pizza party. So let's think about some food in general. Let's think about this example. Here's some letters and what they represent. Okay. Again, that's all an expression is just letters representing something. The first one is M, and I want to practice squaring that off. Man, that's hard. That's just hard. M represents the cost of a main dish. N, all right, that's better, represents the number of side dishes. S represents the cost of a side dish, and T, here we go, represents the total cost of a meal. So keep those in mind. So at this time, if you can pause the video and you can discuss this with somebody or try this on your own, I recommend doing that. What does each equation mean in this situation? So take you a minute, go through, and write down what each of these means in the context of a problem. Understanding how to read math. All right, hopefully you had time. So, what does m equals 750 means? Well, if you look back up right here, m is, well, the cost of a main dish. So this simply means that a main dish is 750. And again, I'm going to get better at my handwriting as we go on. But that's how you read it. What about the next one? Well, main dish is, well, main dish is just a side dish plus $4.50. So understanding what that means if we have a main dish, all right, that's we know that it's going to be a side dish plus about $4.50, which is typically how it works. Your main dish is going to be more than a side dish. All right, what about NS equals 6? Well, again, looking back at top here, what does N mean? N represents the number of sides. So the number of sides times the cost of the sides is $6. All right, so that makes sense, right? You just take however many sides you have, times it by the cost, and in this particular case, it's going to be equal to $6. And that can change depending on what sides you get, but that's what this expression is telling us. And then the last one, M, we know is a main dish. So we take a main dish. We're going to add what we came up with in C, N times S. So add the number of dishes times the cost of the dishes, and that's equal to your total cost. And again, think about it in context of the problem. That should make sense, right? You take your main dish, you add the number of side dishes you have and their cost, and you get your total cost for the expression, right? So that's all we're talking about is how to represent relationships in the context of a problem. And you can come up with as many as you want off the top of your head, like in number 2. So take you a second, maybe try that real quick. Pause the video. All right, so what are some of the ones you came up with? I don't know, you can say that, well, a main dish plus a side dish is equal to $10. I don't know. You can say that the number of side dishes times S um, um, minus a main dish is equal to $2. Doesn't matter. You can come up with whatever you want. Okay? So, the whole point of this, can you read and understand an equation, a relationship? All right, moving on. So, imagine your class is having a pizza party. If you're able to, work with your group, work with some people, try to come up with some way to estimate what the party's going to cost. So in a pizza party, what's a pizza party going to cost? So record your cost estimate, what it would take to convince the class to go with your group's plan, be prepared to explain your reasoning. So if you're able to do this, take you a few minutes, work with your groups, teachers, if you're in the class with them, you're moving around, you're helping the kids as they go. But in this case, don't overthink it. What are the costs? All right, well, um, I don't know. What if we, in this case, we're going to get some pizzas. We're going to get 4 pepperonis. We're going to get 4 cheeses. Cheeses? Is that 4 cheese? And that's good. I don't know. That's just a very, very basic thing. You can come up with all sorts of things. All right. And I don't know. Maybe you're thinking that I don't know. You're gonna end up spending $24 total. I don't know. Just coming up with a number. All right. Um. Now, so like if we come up with $24, or if we come up with any price, what's an expression that can show how we calculated that? All right. I'm kind of ignoring number 1, but let's say that I don't know. Let's say we get some pepperoni pizzas. All right. And the pepperoni pizzas are, I don't know, $4 each. And we're going to get 3 of them. All right. So that would be $12. And let's say the cheese pizza, I don't know, let's say it's also $4. And we're going to get 3 of them. Again, that's $12. And that total would be $24. Again, I'm making this up as you go. Again, this is just another examples as ways to understand how expressions work. Okay. I don't know. So in your expressions, are there quantities that might change on the day of the party? Well, sure. Maybe we're not going to get 3 pizzas. So, I don't know, the number of pizza could change. And I totally made up that $4 for every, or $3 or $4 for every pizza, so maybe that changed. I don't know, things like that, and whatever else you came up with. So keeping that in mind, it says rewrite your expression or expressions, replacing the quantities that might change with variables. Remember, variables are things that change. We usually use letters X, Y, A, B, whatever we want to. Be sure to specify what the variables represent. So, I don't know. I mean, we talked about the number of pizza, and again, we did that for cheese and pepperoni. So, I don't know. Let's let P be the number of pet. Let's let C be the number of cheese. And let's say that, I don't know, the cost for a pepperoni, let's say we figure that out. Let's say we figure that out to be $5. Let's say the cost of cheese we figured out to be $4. Okay. Well, in that case, that would be $5 for every pepperoni plus $4 for every cheese is going to be my total cost. I don't know. That's one way to think about it. But again, can you represent those variables that are changing as letters? Can you write an expression that gives you the total amount? All right, what about constraints in equations? If you're able to, stop the video, read through this, see if you can do number one and number two on your own. This is a great opportunity to, again, try on your own, teachers walking around the classroom, seeing what you can do. All right, so what's the constraint? A constraint is something that limits what is possible or reasonable in a situation. So, for example, one constraint in a pizza party might be the number of slices of pizza each person can have. We'll call that S. We can say that S has to be less than 4, which means each person is going to get fewer than 4 slices, right? So, like, everybody has a limit. That way, not Johnny's over here eating a whole pizza by himself. So look at the expressions you wrote when planning your pizza party earlier. Choose an expression that uses one or more letters. Oh my, what was one that we came up with? $5 for every pepperoni plus $4 for every cheese equals the total. I think we came up with that, right? Well, for each letter, determine what values would be reasonable. For instance, could the value be a non-whole number, a number greater than 50, a negative number, exactly 2? So think about it. What are reasonable values for P and reasonable values for C? Well, I don't know. Can the number of pizzas, which is what that represents, can it be a non-whole number? Well, typically these places don't sell fractional pizzas. Could it be a number greater than 50? Jeez Louise. I mean, it could, but you're spending way too much money and not everybody's going to be able to finish it. Could it be a negative number? Well, no, you can't have negative pizzas. Could it be exactly 2? Sure. So, I don't know. What are some reasonable amounts? P could be, well, it has to be greater than 0. But I'd also say that P would be less than, I don't know, it depends on how many people you got in your class, but less than 5. Same thing for cheese. Oops, sorry, that meant to be 5. So your cheese can be greater than 0. Your cheese also has to be less than like 5. That way you're not ordering too much and it's fairly reasonable, right? All right, also, write equations or inequalities that represent some constraints in your pizza party plan. If a quantity must be an exact value, use the equal symbol. If it must be greater or less than a certain value to be reasonable, use the less than or greater than symbols, which again, you've done this a lot. Um, and to be fair, we already did that in part B. Whoops. I guess more so part B was asking about non-whole numbers or greater than 50, all those things. But really, we kind of came up with some reasonable constraints right here. Um, and that could vary, right? You could say pepperoni can be between 0 and 5 or 0 and 10. Or you could say, if you want to be exact, you can say, hey, here's my constraint. You have to have 2 pepperonis. You have to have 4 cheeses based off of what maybe students in your class say. These are constraints. These are like constraints. Either you're giving you a range of what the variables can be, or you're saying exactly what the variables have to be. All right, so again, the whole point of this lesson was for you to kind of explore on your own. So hopefully you stop the videos a lot, trying to um, figure out these problems on your own. But the whole point is to understand the relationship between constraints and expressions, knowing how to write relationships, that kind of deal. So we're just going to kind of summarize real quick here with our fill in the blanks here. See what you can do on your own, but just kind of follow along as well. So, to summarize, expressions, equations, and inequalities are mathematical, we'll call those mathematical models. They are mathematical representations used to describe quantities and their relationships in a real situation, which we've already talked about. Often, what we want to describe are constraints, right? We want to know our limitations, our what our values can and cannot be. And a constraint is something that limits what is possible or what is reasonable in a situation. For example, when planning a birthday party, we might be dealing with these quantities and constraints. So these would be quantities. So the number of guests, the cost of food and drinks, the cost of birthday cakes. Like these are things that can change, right? We don't know how many guests we're going to have. We're not, we don't know what the costs are going to be. These are quantities. These are variables. And then our constraints could be that, well, we have, for our number of guests, we can't go more than 20 people. It has to be 550 per person. $40 for a large cake. You get the idea. Okay. So keep in mind we can use both numbers and letters to represent the quantities. For example, we can write, I don't know, 42 to represent the cost of entertainment, but we might use the letter, I don't know, letter N to represent the number of people at the party, and the letter, I don't know, total cost, maybe letter C for the total cost in dollars. So variables we try to write with letters. Things that we may know are going to be certain we can write as numbers. All right. We can also write expressions using these numbers and letters. So kind of what we've done all day today. For instance, the expression 550N is a concise way to express the overall cost of the food. if it costs $5.50 per guest and there are n guests. Sometimes a constraint is an exact value. Like for instance, the cost of music, like in the chart in the previous slide, is $15. Other times, a constraint is like a boundary or a limit. For instance, the total cost must be no more than $180. That's a limit. And in our expressions, symbols such as less than, greater than, and equal to can help us express these constraints. That's all an expression or an equation in real world time is. All right, so looking at that chart, here's some of the constraints we can write with letters and numbers. Equations can show the relationship between quantities and constraints. And restraints. For example, the total cost of the party is the sum of the cost of, all right, total cost of the party. Well, that's going to be the cost of the food. That's going to be the cost of the cake. That's going to be cost of the entertainment. Now, thinking about the food, thinking about the cake, thinking about the entertainment, those are our three costs. Number of guests, that's not contributing to the cost until we plug it into these equations, but those are where our three costs come from. Well, I know that the cost, the total cost, C, which is less than 180, is going to be equal to the cost of the food and the drinks, which is $5.50 for every guest, plus $40 straight up for the cake, plus the total cost of entertainment, I guess, is 15 plus 27. And if you were to simplify that by like adding these three numbers together by combining like terms, that's just 550 n plus, and if you add those three numbers together, it's 82. And then deciding how to use numbers and letters to represent quantities, relationships, and constraints is an important part of mathematical modeling. Going back to modeling. Making assumptions about the cost of food per person, for example, is also important in modeling. A model such as, well, the equation we came up with, but that is a model, that is an equation, can be an efficient way to make estimates or predictions. When a quantity or constraint changes, or when we want to know something else, we can always adjust the model and perform a simple calculation instead of repeating a series of calculations. So, all right, really the big thing here, guys, is that we wanted to learn how to read and understand a relationship of letters and numbers and constraints, all the things. Being able to take an equation in the context of the problem and know what it means. Okay? So, that concludes our first video lesson on equations and variables and constraints. Hopefully that helped a little bit. And that's going to be kind of the way that it goes in each of these lessons. We're going to have an intro. We're going to have some problems that you'll hopefully be able to reason through on your own. And at the very end, we'll try to summarize with a few fill in the blanks. All right. Alrighty. Thank y'all very much. Forbes out.